topic that we study today is called Newton's laws of motion, and very, I don't know how do I do justice to myself while I'm teaching you this. They have done it in exactly half of pages. They have explained it, but that way you will not understand the beauty of Newton's law of motion. So let me just see. They have said first law, then they have said second law, and they have done third law, all in one page. Okay, so let's try and understand. Come. Newton's laws of motion are also read as NLM. Newton's laws of motion. So the laws of motion were given by Sir Isaac Newton. Now there are a lot of stories. थोड़ा जानना चाहोगे? अच्छा लगेगा. ऐसे this is absolutely will not give you pleasure. Okay. So the type of physics that you are studying now are called classical physics. These physics belong to the era of 17th century and all. ठीक है? ये बहुत पुराने चीजें हैं. Mechanics जिसको बोलते हैं. Here you won't see anything called semiconductor or charges or atom, electrons, because nothing was discovered. What you will see here, a mass tied with a rope, monkey tied with a rope or something like, where is this mass going? So this is the basics of mechanics, Newton's laws of motion. So the first chapter we used to call kinematics, where we were only talking about motion, uniformly accelerated motion in a straight line, and we were discussing about facets of motion: velocity, displacement, acceleration, initial velocity, final velocity. Nowhere did we talk about, and the problems were like this: a body moves with the initial velocity, but you didn't question, I didn't question, why is the body moving? We did not understand the reason behind the motion. We only studied the facets of motion. Got it? So when you start understanding the reason behind the motion, the subject is called kinematics. So one side we have, like, everything is dynamics, kinematics, this is kinetics, where we try to understand what are the reasons. So one of the main reasons we understood about force, which we have already discussed. Now, talking about Newton's laws of motion, some very interesting things. Newton's laws of motion are never proved. There is no proof of any law of motion. But nothing happens in this universe that happens against the laws of. Nothing has been found that contradicts these laws. Newton's laws of motion are valid for a Newtonian environment. What is a Newtonian environment? An environment where system does not have any interchange of anything with the surroundings. Something like वहाँ पे friction type चीजें नहीं होता है, ठीक है? Resistance, like air resist, like we say a ball is thrown up and we just take G as our calculation. We think that there is no air resistance, but actually there will be a lot of air resistance. When you come down, your clothes will be fluttering like anything. So Newton's laws are valid for Newtonian environment. However, we study them. Now, in order to study Newton's law, Newton's laws always tells us about force. हमारे पास Newton, just 1 minute, I don't know this minute. Urgent? ठीक है, class है, हाँ. Yeah. So Newton's laws are 3 laws. We have got 3 laws of Newton, and all the 3 laws will speak something about force. Something about force. So our first question arises: does Newton's law define about force? I would say yes. Therefore, you need to understand force to know Newton's laws. That's why we covered force at first. But your concept about force will improve a lot once you understand Newton's laws. And the point is not about mugging up those laws, like what is the first law, what is the second law and third law. But many of the children during even an interview are unable to explain what first law means, what second law means. Okay? So we start with the first law of Newton, and very interesting thing, before Newton, there was one more person in Italy, and his name was Galileo. Have you heard about Galileo? Okay. Galileo conducted a lot of experiments from the Leaning Tower of Pisa. After Galileo died, 1 year later, Newton was born. तो ये मत समझना सब कुछ न्यूटन का ही कारोबार है. Newton's first law of motion, although the books are all speaking all about Newton, is also known as Galileo's law of inertia. Galileo's law of inertia. And in fact, if you read Newton's book, which is called Principia, in Principia, whatever Newton has written, that book is written in Latin, whatever Newton has written is exactly same with Galileo's law of inertia. लेकिन ज्यादा फेमस न्यूटन्स फर्स्ट लॉ, न्यूटन्स फर्स्ट लॉ हो गया। ये लॉ पहले भी लोगों को पता था। पहले इस लॉ को समझने की कोशिश करते हैं, देन विल ट्राई एंड सी। सो व्हाट गैलीलियो डिड, गैलीलियो कंडक्टेड एन एक्सपेरिमेंट समथिंग लाइक दिस। सी, say for example, he designed he designed an apparatus like this, and he saw that if you actually take a ball and you take the ball from this height and you let the ball fall here, the ball rolls and exactly climbs to this height only. These are Galileo's observations. First ball was released, the ball falls और यहां जाके exactly ऐसे जाता है, ठीक है। In the next experiment, what he did, in the next experiment, he took the same thing, ऐसा ही, और थोड़ा और फ्लैट कर दिया, ऐसे करके फ्लैट कर दिया, and he released it from this height, and he found the ball goes this way and again climbs to a position where the height is exactly the same, ठीक है। And out of curiosity, we may also ask, so what will happen? Say, suppose if the ball is released from here and this side is this much. Every time that thing which we are finding is the ball climbs the same height, and to climb the same height, the ball is ready to travel a linear distance. लेकिन उतना ही height तक जाएगा। Third question में हमने अलग किया, we given the ball a height, but on the other side we did not give a height. यहाँ पे क्या होगा पता है? The ball will come here and go straight till this height, and after that it will take a trajectorial motion. उतना तक सीधा उठ के फिर ऐसे गिरेगा, टक 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 टक, यहां से ही नहीं गिरेगा, इतना तक सीधा जाएगा, right? So he started asking that every time what is happening, why is the ball going only up till here, why is the ball going only up till here, and why is the ball not traveling, इससे ज्यादा हाइट क्यों नहीं जा रहा है? जरा सोचो, बॉल इतना ही क्यों गया और ज्यादा ऊपर क्यों नहीं गया? क्यों नहीं गया होगा? हाँ, आई एम आस्किंग यू, व्हाई डिड द बॉल, सपोज ये और ऊंचा कर दो इसको, बॉल और ऊपर क्यों नहीं गया, यहीं तक ही क्यों गया? नहीं ठीक है, पर यहां तक ही, यहां क्यों नहीं गया? Oh, it's all being done on Earth. There is gravity also, na? Gravity is pulling it. That's right, putting your knowledge that you have acquired this motion in a straight line. There will be an axis, a retarded motion. The ball doesn't go in this way. Retarded motion में क्या होता है? Final velocity जाके zero हो जाएगा. Acceleration इसके खिलाफ है ना? Gravity is acting. So he started thinking कि अगर मैं, so everywhere you see there is a motion which is opposing this motion of the ball. If somehow this was made long, this platform was made long, and then the ball was released, तब ball कहाँ जाना चाहिए? जरा सोचो फिर से, you all don't think, that's why you all are unable to answer. In the first, he had curved on both sides. Ball released from here, climbs till here. What he did, he reduced the slope. He still found the ball travels till here and goes here. If he reduces the slope further and again makes it inclined, the ball will travel this distance and yet climb there. And in one case we saw if you make it less, the ball still climbs to the same height and then falls. My question is, now we have made it long. No, it's straight now. Straight. अब बॉल कहां क्या होना चाहिए? सोचो, यही तो गैलीलियो का लॉ है. What should happen? थोड़ा सोचो, आपको रिलेशन मिलना शुरू हो जाना चाहिए. यहां से छोड़ने से बॉल यहां जाता है, इसको जैसे ही मैंने फ्लैट किया फिर भी बॉल अपना हाइट मेंटेन करता है. मैंने और फ्लैट कर दिया, आई हैव मेड इट मोर फ्लैट, फिर भी बॉल अपना हाइट मेंटेन करेगा. इस बार मैंने फ्लैट करते करते एकदम ऐसा कर दिया, स्ट्रेट कर दिया. अब बॉल कहां जाना चाहिए? हाँ, जस्ट कीप गोइंग. रुकेगा. My question, please participate. Will the ball stop? Why? Why does it lose energy and momentum? Is used in traveling the distance? No, you lose energy only when you are trying to fight with something. Friction है. Friction गायब कर दिया. No friction, no air resistance. It'll keep traveling. कब तक? Forever. This is Newton's first law. दिस इज न्यूटन्स फर्स्ट लॉ. दिस इज कॉल्ड गैलीलियोस लॉ ऑफ इनर्शिया. जरा सोचो, मैंने आपको बोला ना न्यूटन के लॉस कहां पे चलते हैं? ऑल इन न्यूटोनियन एनवायरनमेंट. वी विल से सर अगर मैंने फुटबॉल ऐसे छोड़ दिया, फुटबॉल विल गो एंड स्टॉप समवेयर बिकॉज देयर इज फ्रिक्शन विद द फुटबॉल. एयर रेजिस्टेंस, ग्राउंड में फ्रिक्शन हो रहा है. सपोज देयर इज नो फ्रिक्शन, so what children do? They memorize Newton's first law. Newton's first law is very interesting. अब इस डायग्राम को थोड़ा सा मिटाता हूं and let's discuss upon the definition of Newton's first law. Don't write anything, try and enjoy. Newton's first law, the first part of Newton's first law, everyone finds it very easy, and that is not easy, your heart accepts it. Newton's first law says a body at rest will remain at rest. Where am I? At rest. Will I remain in rest? Yes, I am remaining in rest. इसको हमारा हार्ट मान लेता है. अश्मिता बाद में लिखना आराम से, मैं पूरा बताऊंगा, अभी सुनो, समझो पहले. A body at rest remains at rest. You came to my house and you kept your water bottles. Have they moved from their places? No. So my heart agrees to the first part, but the next part is something that your heart will not agree. And the body in motion continues to be in motion. अगर कोई चीज हिल रहा है तो चलते ही रहेगा. ये हमारा मन नहीं मानता है. बॉल रोल करके दे दिया, थोड़ी देर बाद जाके रुक जाता है, राइट? पेंसिल ऐसे रोल कर दिया, थोड़ी देर बाद जाके रुक जाता है. दिस इज व्हाट इज कॉन्ट्राडिक्टिंग. डजंट हैपन समथिंग टू आवर डेली लाइफ. नाउ लिसन टू द सेकंड पार्ट. अ बॉडी एट रेस्ट रिमेन्स एट रेस्ट. अग्रीड. अ बॉडी इन मोशन continues to be in uniform motion. Newton's first law itself takes 1 hour to understand, and your book has done half of page in all three laws. Continues to be in uniform motion. What is uniform motion? Equal distances in equal intervals of time. Velocity is uniform, no acceleration. Unless and until it is acted upon by an external force to change its state of rest or of uniform motion. अभी भी आप कुछ नहीं लिखोगे, मैं बोर्ड में लिखूंगा, हम हर एक पार्ट को समझेंगे, तब आपको मजा आएगा. इट सेज, गैलीलियो के लॉ ऑफ इनर्शिया को भी लिखेंगे. व्हाट इज न्यूटन्स फर्स्ट लॉ एंड गैलीलियोस लॉ? इट सेज अ बॉडी एट रेस्ट, प्लीज डोंट राइट, ट्राई टू ऑब्जर्व, एट रेस्ट रिमेन्स एट रेस्ट. ये पार्ट हमारा हार्ट एग्री करता है, रिमेन्स एट रेस्ट. एंड a body in motion continues to be in its state of uniform motion uniform motion in a straight line. Actually, it's not right. Uniform motion itself means motion in a straight line, unless and until it is acted upon by an external force to change its state of rest or of uniform motion. Pardon my handwriting. Let's now read every part of it. A body at rest remains at rest. A body at rest remains at rest, right? And a body in motion, some value. And a body in motion continues to be in its motion of uniform motion in a straight line. ये रुकेगा ही नहीं. सर स्कूल बस तो रुकता है, सब कुछ रुकता है, बहता हुआ पानी भी रुकता है, समय नहीं रुकता है. नहीं, सब रुकता है. Unless and until in a state of uniform motion, that means acceleration will be zero and v will be constant. It will keep on moving. Uniform motion in a straight line. Unless and until it is acted upon by an external force. Now you tell me, if I roll a football, will it stop on the ground? Yes. It does not continue in its uniform motion because it is acted upon by an external force, that is the friction of the grass. the gravity, the weight of the ball, the air resistance, all of them are, अब तो एक force बोला होगा, तीन force आ रहा है, all of them are acting on it and changing its state of uniform motion, changing its state of uniform motion. और रेस्ट के लिए भी वही है, I am at rest, I continue to be at rest unless somebody kicks me and I get into motion. बात समझ में आया? So a body at rest remains at rest unless it is acted upon by an external force to change its state of rest. Very well, heart agrees to it. And a body in motion continues to be in motion. That is where the heart doesn't agree. But that experiment which I showed you, and you only said that the ball should keep on rolling, rolling, rolling till eternity. You and me may die, but the ball will still keep on rolling as long as it is uniform motion in a straight line. But on earth, you cannot create a straight line till eternity. And there should be no external forces acting on it. This definition of Newton's first law is not that important. How much are you able to extract information out of it? Which means that if a body, you can even go to CBSE grade 9 laws of motion first class. If a body is in rest or if a body is in uniform motion, one thing I have understood from this law is that the net force acting on this body is zero. The net force acting on this body is zero. That's what the law says. Because if some force would have acted on it, its state of uniform motion will be disturbed. If some force would have acted on it, its state of rest would have disturbed. Sahasra is sitting on her seat and we are pulling her by her right hand, we are pulling her by her left hand. Is she under a system of forces? Yes. What is the net force on her? Zero. So she is still at rest. And there comes me and I now push her. Has an additional external force come in? We have disturbed your equilibrium. Your state will change, you will immediately fall. From rest you get to motion. Are you understanding this thing? Let us try and understand. Don't go by this definition. आपको लिखाऊंगा, बहुत सारे books में मिल जाएंगे. आप पहले example समझो. So, as I told you, Newton's first law gives me the definition of force. But sir, I learned force before that. That is to understand this particular definition. अभी आएंगे. मान लो, ये is a very nice example. This is your car. A car at rest remains at rest unless and until it is acted upon by an external force. You can push the car or the engine can give a force to which the car moves. So first part of Newton understood. Suppose this is a car and we are going on a straight stretch of road. We are going on a straight stretch of road, right? And this is real life, on a straight stretch of road. And let's say the car right now is going at 50 kilometer per hour. Try to find out. Is this a straight stretch of road? Yes, 50 kilometer per hour. So is the velocity of the car uniform? Straight ja raha hai 50, speed constant, direction constant, velocity constant. What about the acceleration of this car? The acceleration of the car is zero. Can I now right now say that the car is in uniform motion? Yes, the car is in uniform motion. But Newton says during uniform motion, no net force should be acting on the body. क्योंकि अगर नेट फोर्स आ जाएगा तो गाड़ी का यूनिफॉर्म मोशन का तो तालमेल बिगड़ जाना चाहिए. आओ देखते हैं, क्या ये गाड़ी का कोई वेट नहीं है ना? देयर इज वेट. क्या ये गाड़ी के टायर्स उसको फ्रिक्शन क्रॉस नहीं कर रहे हैं? कर रहे हैं ना. क्या इसमें एयर का फ्रिक्शन नहीं हो रहा है? ड्रैग हो रहा है ना, राइट? देयर आर थ्री फोर्सेस विच आर एक्टिंग अगेंस्ट योर डायरेक्शन ऑफ ट्रेवल. ड्रैग, tire friction, and your weight. Weight is also a force. There are three forces which are acting against you. For simplicity of physics, I have changed these three forces and I have called them as one force called F enemy. This is my enemy force. ये मेरे को यूनिफॉर्म वेलोसिटी मेंटेन करने नहीं दे रहा है. This is an enemy force. So sir, please show the direction of the enemy force. So overall combined effect of everything, vector diagram करके I am showing that this is my F enemy. And you won't deny with me, F enemy is acting against you, right? You are still maintaining 50 kilometers per hour. That means you should have some force which is tackling this F enemy. And for that force, your so-called the car owner has spent 20 lakh rupees to buy that beautiful Mercedes Benz or whatever engine as you call. So the engine is giving a force, which is the F engine. My F engine is tackling this force right now, and my car is able to be in uniform motion. However, this engine force is in my control through my gas pedal. ज़्यादा बढ़ाऊंगा तो engine force आ जाएगा, बढ़ जाएगा, so I can control it. So whenever you are going at cruise, the car is going at cruise. Cruise समझते हो? You can cruise. Cruise means your car is in uniform motion. Now apply Newton's law. A body in motion continues to be in uniform motion in a straight line unless and until it is attacked upon by an external force. So let's create one more external force, shall we? So let's create one more. F enemy. So right now what is the relation out here? F enemy is equal to F engine. And so we will say, what is the F net? बोलो ध्रुव, F net कितना होगा? ये दोनों अगर equal है तो F net is 0. If F net is 0, then the net acceleration acting on the car is 0. Acceleration is 0. Net acceleration means if I take this car separately out, there is no net force acting on the car and there is no net acceleration. Is this much understood? Let's now make our journey a little bit more interesting. अब हम क्या करते हैं, रोड को थोड़ा सा स्लोप डाउन कर देते हैं. ऐसे रोड को हमने स्लोप डाउन कर दिया, राइट? स्लोप डाउन करते क्या हो जाएगा? अगर हम इंजन का सेम, इफ यू कीप द इंजन, नाउ व्हाट विल हैपन? द कार विल बिकम फास्टर, agreed, and gravity will pull the car downwards. So the gravity is now is acting in my benefit. So F enemy का वैल्यू कम गया यहाँ पे. So right now if I make it this way, this is my scenario 2. Don't you agree? In scenario 2, F enemy has become less than F engine. If this is there, then don't you think you have created an unbalance? If there is an unbalance, don't you think you have created an F net? Yes. So now in scenario 2, I can say that there is a net force acting from behind the car. Obviously, behind the car ही होगा ना, it is supporting, either you are pulling the car or from behind the car. There is a net force acting in this side. Does the body acquire acceleration? Yes. There will be a net also which will come into this body. Do you agree? Is the body in uniform motion? No. No. Once acceleration comes in, where do you have uniform motion? So go back to Newton's first law. A body in motion continues to be in uniform motion unless and until it is acted by an external force. So an external force came up. That was the force of gravity which is pulling the car down. And we replaced everything and we said, now there is no more, net force is no more 0, but there is one ultimate force acting on the car. Will the car retain its uniform motion? No. That's what Newton says. Unless and until it is acted upon by an external force to change its state of rest or of uniform motion. We are only discussing uniform motion. Rest is easy to understand. So its state of uniform motion has got changed. Yes.
Sure.
Yeah, one by one. I'll take his question, then I'll come to you. Yeah. Uniform, what is the condition of uniform motion? You so far you have studied uniform motion only in chapter 1. You never heard about force. Please understand that. So talk from that knowledge level. Chapter 1, uniform, what is uniform motion? A body is said to be in uniform motion if it covers equal distances in equal intervals of time, no matter how small the time intervals are, and it travels in a straight line. Straight line, because then only the velocity will be constant. It was straight before this, and we were traveling at 50 km per hour. Aren't we not in uniform motion? We were in uniform motion. Our acceleration was 0. Now we have suddenly made the road slope downwards. And with the same, see, till now, this was the arrangement. F enemy was 5 and F engine was 5 Newton. Balance system, right? Till now we were in this direction. It was balanced. Suddenly this slope came up. After the slope came up, our calculation became something garbar. This became 3 Newton. This continues to be in 5 Newton. Are the system of forces balanced now? No. So now we can say that we have a net F of 2 Newton acting behind the car.
So F net should be.
There is a F net. End of the day, there is an F net which has come up. So the net force is now no more 0. If the net force is no more zero, that means the body is acted upon by a force. And that's what Newton says. If you are acted upon by an external force, you cannot enjoy the privilege of uniform motion. Sir, I don't enjoy. And in previous class, we had studied that father equal to mother, ma, F equal to ma. That means if a F net has come, then don't you think you can use this relation now, F net equal to mass of the car into A net. We will use this relation little bit later. अभी अभी ऐसे देख लो. A net आ जाता है. You saw weight का definition देखा था ना, W is equal to M into G. A force is always a mass into acceleration. That same thing we will come here. Don't break your head. Right now you should understand one thing. Newton says, if I'm at rest, I remain at rest. Still, no net force acts on it. That does not mean if I'm on rest, forces are not acting on me. I gave the best example by pulling her right hand and left hand. Forces were acting on her. Yet, sir, she is not moving. That means net force is zero. Tug of war. Forces acting. Forces acting. People are having stressed faces, nerves coming out. Forces are acting. उस वक्त आप एक आपका भाई को ले जाओ, आपके भाई को ले जाओ, वो तो क्लास 6 में पढ़ता है ना, छोटा, वो जाके अगर किसी भी अंकल को पकड़ के ऐसा कर दिया ना, वो पूरा टीम हार जाएगा. क्यों? आपने रेस्ट में था, वो लोग सब रेस्ट में थे, यहां से आपने एक इम्बैलेंस कर दिया, and that imbalance was done by a toddler. No matter, doesn't matter. The right hand side force is more. And say suppose if you add up, they are pulling by 500 Newton, they cannot give more than 500 Newton. And your brother's capability is only bringing 1 Newton. How much is this side then? 501. Then can we, in tug of war, have you seen there is a ribbon on that? So now that ribbon which was tied, I just make a simple free body diagram and I show that the ribbon is being pulled by 1 Newton. This is your brother. The ribbon moves this side. His state of rest has changed because a net force has acted on it. किसा समझ में आ रहा है? ये हाफ पेज में नहीं होता न्यूटन का लॉ. अब उल्टा देखते हैं. I'll come to your question, Ashmita, don't worry. रास्ता को ऐसे बना दो, ऐसा भी हो सकता है. Now what will happen? The enemy force will become more strong. वो लोग आपको नीचे दबाएगा because now gravity is pulling you downwards. Still also if you want to maintain 50 km per hour, don't you think your accelerator has to be pressed now? In this scenario, what is happening? Sir, in this scenario, F enemy has become greater than F engine. This has become 7, this is still 5. So how is the scenario looking like? Sir, the scenario is now looking like something like this. That I am being pulled by, I am being pushed by 2 Newton from this side. Will I retain uniform motion? No. So what is the crux of Newton's law? ये जो हमने इतना पढ़े, न्यूटन के फर्स्ट लॉ का एक ही रूल है, समझोगे उसको 1 मिनट में हो जाता है. If in any physics problem you are given a system and in that system after working vectors of all forces, suppose I give you a system in which I am pulling it like a medical cross, this side 2 Newton 2 Newton, 8 Newton 8 Newton. What is the net force on y-axis? 0. Net force on x-axis? 0. But suppose I don't give you simple like this, I have given you something complex system of forces and you did all vector addition. और वेक्टर एडिशन करके आपने बोला, जयदीप सर फाइनली इस साइड में एक फोर्स मिल रहा है 2 न्यूटन एट 30 डिग्री में मिल रहा है सर एक्स एक्सिस का. यू फाउंड दिस बाय सम वेक्टर डायग्राम. एफ नेट. नेक्स्ट थिंग योर ईयर शुड से सिस्टम में ए नेट आ गया है. थिंक अबाउट फोर्स, द एक्सेलरेशन इज बॉर्न. दैट वाज योर प्रीवियस चैप्टर. सो इन ऑल योर प्रीवियस चैप्टर, wherever you had a problem with acceleration, those systems are all subjected to force. Force रहना ही पड़ेगा. अगर force नहीं है, कौन सा force? Net force. If net force is 0, then acceleration in the system is 0. I used to give a very nice example. Nidhi and Kirtan can understand. Ashmita cannot. You all open my door and come inside. For the last 4 days, it has been heavily windy. Right? My door, Ashmita, the door on my house has got a door closer also out here. Just like hotels mein jaise door closer hota hai, there's a door closer. When the children used to open this door and the door used to open up like this, a door ऐसे खुल गया है, The fascinating thing that used to happen is the door used to still stand. Is the door closer not pulling it to close it? Yes. Why is it not closing? The wind is again opposing it. A body at rest remains at rest. Newton's first law. All the class 9 CBSE and the 10th, you all didn't come in those days. If I open this door right now, the door will ऐसे खुला रहेगा, बंद नहीं होगा क्योंकि हवा बहुत ज्यादा है बाहर. In normal days, what happens? There is no hawa outside my house. So who is winning the battle? The door closer wins the battle. धड़ाम करके बंद कर देता है उसको, रेस्ट में रहने ही नहीं देता है. पर दूसरे दिनों में क्या रहता है? हवा भी है. ऐसे हवा खींच रहा है, ऐसे डोर क्लोजर खींच रहा है. Apparently, I find that my door, like our Kirtan, we used to say, na, Kirtan, close the door properly. If Kirtan doesn't close the door, then what happens? The door opens on its own and stays there. Stays there. A body at rest remains at rest. Our force is not working on it? Yes, sir, working. But net force is zero. And if net force is zero, then acceleration is zero. This will help you a lot when you do mechanics. If you continue in Cambridge in 11, then we go to AS level physics. You will find that there will be a lot of mechanics problem where you will see, sir, net force आ गया है body में. Net force आ गया तो acceleration आ गया. और net force नहीं है तो acceleration नहीं है. Now let's go back to Newton's first law. A body at rest remains at rest, very good. And a body in motion continues to be in motion, very good. Our heart doesn't agree, but now it agrees because we have seen Galileo's explanation, we have seen F enemy wala explanation, we have seen the door closer explain. It continues to be in motion unless and until it is acted upon by. Sir, every evening I roll the ball. You mean to say that the ball should keep on rolling? Yes, darling, the ball should keep on rolling. Why does the ball not keep rolling? It is acted by an external force like the friction of the grass, the drag, the weight of the ball, all acting against you. That's Newton's first law. So Newton's first law defines force. Now you go back to when we studied force. We studied three aspects of force. A force is an external influence which can bring a body from rest to motion. Didn't you study? Motion to rest. Didn't you study? Can change the speed of a moving body. Didn't you study? Can change the direction of a moving body. Didn't you study? Speed, direction together, can I not change? Can I not say can change the uniform motion of a body? I am saying I change Dhruv's speed and Dhruv's direction. That means I can say I have changed Dhruv's uniform motion. Dhruv was sitting here, I kicked him and he rolled over the bed. I put him from rest to motion. He was running towards me and I pushed him, he could not run further. I put him from motion to rest. वही सब चीजें तो फर्स्ट लॉ बोल रहा है. फिर से सुनो तो फर्स्ट लॉ. A body at rest remains in rest. And a body in motion continues to be in its state of uniform motion in a straight line. फिर प्रॉब्लम क्या है सर? Unless and until, कब तक? तब तक it is acted upon by an external force to change its state of rest or of uniform motion. So let me twist the definition. An external net force has the capability to change the uniform motion of a body as well as to change the state of rest of a body. Now put this statement into three classes before today. Force can bring a body from rest to motion. Yes, just call it net force. Force can change the speed and direction of a body. Yes, just tell it net force. And if that happens, a net force always comes with its child. Who is it? Acceleration, a net. Is acceleration a vector? Obviously, born out of velocity, who is a vector. So acceleration should have some direction. What is the direction of acceleration? The direction in which you are having the force. अगर enemy force इस तरफ है तो acceleration इस तरफ है, पर गाड़ी के लिए वो क्या बन गया? रिटार्डेशन बन गया, नेगेटिव एक्सेलरेशन, इसलिए गाड़ी स्लो हो जाता है. अच्छा, अभी सोचो, अगर पीछे से हवा चल रही है तो फोर्स इस साइड है, force is behind me, acceleration is behind me. That means my velocity increases. In higher level, grade 11, tier 11, we say the same thing. If acceleration and velocity are in the same direction, the speed will always go up. Kick yourself from the back. Force is in this direction, acceleration in this direction. My velocity is also in this direction. My speed increases. Make it separate. Acceleration in this direction, velocity in this direction. So I am running in this direction, Hawa is coming from that direction. Speed reduces. Sir, acceleration in this direction, speed in this direction. Still speed will increase. Got it? So Newton's first law will tell me only about one thing. If Fnet comes into picture, please, my dear students, ANet. In grade 11, we just read it like that. An Fnet brings an ANet. My so-called obsession for the law and explanation, which is not with this book, ends here for questions from your side. I am still to tell you about Galileo's law of inertia, which is exactly word by word same. In fact, Newton ने गैलीलियो के फर्स्ट लॉ ऑफ इनर्शिया को चेप दिया है और नाम उसी का है, वैसे ये लॉ गैलीलियो का है। वो बताऊंगा, तब तक मैं इसको मिटाता हूं और आपको जो भी सवाल है आप पूछिए। पहले आप उस लॉ को लिखने की कोशिश कीजिए अभी। एंड इफ यू थिंक यू आर गेटिंग स्टक अप फॉर वर्ड्स, आस्क मी, आई विल हेल्प यू। अ बॉडी एट रेस्ट, पहले अपने मदर टंग में समझिए। इफ somebody is at rest, it will remain in rest, and a body in motion continues to be in a state of uniform motion in a straight line। ये वर्ड याद कीजिएगा, इतना लिखो तो। a body at rest, a body at rest, that part you write with one ink. Today I'll ask you to, yeah, yes sir,
Sir, one more.
yeah.
So, sir, there's gravity also acting on an object. So, sir, how is that a cause? Like to have Fnet as zero?
Gravity is also acting, then what did you say, Bitu?
Sir, won't it affect the law?
Yes, that's why you are spending so much to buy the engine of a car. That's why you are unable. Otherwise we would have never needed an engine in car.
No.
Just think, if you are in a Newtonian environment, what is a Newtonian environment? Sir, there is no drag, no studies, no wake up early, sir, no parents who will always keep on telling you, sir, no teachers to scold you. Isn't it a lovely environment? Lot of food, no indigestion problem. Newtonian environment, everything is gala gala, fairy fairy. So in a Newtonian environment where there is no force, no sort of friction and other thing happens, there a body in motion will be in motion. In fact, next time if you all go to a science museum, ठीक है, एक मिनट साथ साथ सुन लो, अगर आप साइंस म्यूजियम जाओगे तो साइंस म्यूजियम में there are always some things displayed which are called perpetual motion machine, and those machines will be like some spirals, they keep on moving. Perpetual motion means आज से लेके हमेशा के लिए मूव करता ही रहेगा. Is it possible in our real life environment? No. They use motors and all. What they are trying to show is that perpetual motion machines are the conceptualized machines of Newton. ऐसा अगर होता तब तो एनर्जी नहीं चाहिए होता. यहां से पानी छोड़ देंगे, एकदम सहस्रा के घर तक जाएगा, बॉडी इन मोशन कर दे. बट विच फेसेस बेंड्स, स्लोप्स, अप, फ्रिक्शन, इसलिए नहीं जा पाता है.
This is not practically, it cannot happen practically. You need some-
It does happen every day practically, because you just see the opposite. See what is happening. You may ask this question, I'll answer from mythology. You will say, sir, वो होता नहीं है सर, सच्चे लोग कभी होते नहीं, वो किताबों में होता है, क्योंकि तुम चोर देख देख के तुम्हें आदत हो गया है.
Okay.
Because in your world that you see around you, there is gravity and other things. It is happening practically when you are driving on ORR and you are coming to Pebble City. At some places you are putting your car on cruise. Cruise means the car goes at a constant speed, straight line. You yourself made net force zero. You cannot take care of friction, वो तो रहेगा. You cannot take care of gravity, वो तो रहेगा. You cannot take care of air resistance, वो रहेगा. तो आपने क्या किया? आपने अपने अंदर से एक फोर्स पैदा किया, 20 लाख रुपया खर्चा करके गाड़ी का, F engine, and that is now countering that dushman. And if you overpower the dushman, then you are accelerating. You cannot be in cruise. And if you are underpowered, then after some time you will go and stop. जोर से साइकिल चलाओ बेटा, पेडलिंग करो, बहुत जोर से पेडलिंग करके suddenly release the pedals on a straight road. You will go up to somewhere, but then you will stop. Why? Because friction, air resistance is acting against you. You are no more under uniform motion.
Okay, sir. So, sir, when Fnet is zero, then only it is in uniform motion.
A body, whenever it is in uniform motion, there is no net force acting on it.
Yeah.
No net force means no net acceleration. And what is the definition of uniform motion? No acceleration. So we write down, a body at rest remains at rest, and a body in motion, yeah, thank you. A body in motion continues to be in a state of uniform motion in a straight line. Continues to be in a state of motion in a straight line unless and until it is acted upon by an external force to change its state of rest or uniform motion. एक्चुअली दो पार्ट में लॉ को बताया गया है, रेस्ट को लेके एक बार बोला है, यूनिफॉर्म मोशन का. बॉडी एट रेस्ट रिमेन्स एट रेस्ट and the body in motion continues to be in a state of uniform motion in a straight line unless and until it is acted upon by an external force to change its state of rest or of uniform motion. और नीचे लिखिए एक अलग से, this external force is called the F net. So remember the okay, are you all done writing? Then we'll speak. A body at rest remains at rest and a body in motion continues to be in a state of uniform motion in a straight line unless and until it is acted upon by an external force to change its state of rest or of uniform motion. Have you written? Are you being slow choices? I've written that so faster than you. Not yet done? Okay, now again think our car example. F engine equal to F enemy. Body continues to be in uniform motion. For examples of uniform motion, rest, Sahasra sitting, right hand pull, left hand pull, Sahasra still sitting, body at rest. In both the cases, forces were acting on it, but the forces cancelled each other. So the net force on the body was 0. So Sahasra continued to be in rest and the car continued to be in uniform motion. Then came a naughty boy like Jaideep Das and he pushed Sahasra and the other children who were pulling her on either sides. He pushed that entire system. Did he imbalance the setup? Yes. He created an F net. Sahasra fell down. She is no more under rest. Point at rest. Let's go to the car. And then I came out like a demon on the road and I blew air from my mouth, which caused the car to go more faster. Have I disturbed the uniform motion? Yes. Is the car having a net force now? Yes. Like a Dracula, I'm blowing air, ha 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 ha, ऐसा कर रहा हूँ, और गाड़ी, that's the net force that is acting on the system. Body is no more under uniform motion. Are we fine on this? So Galileo's law of inertia states the same thing. A body at rest remains at rest and a body in motion. Rather, Galileo, more than rest part, Galileo talks only on the motion part. The body in motion continues to be in a state of motion unless any external force is influenced on the body to change its uniform motion. Otherwise, the ball keeps on going. However, we got a rule about something called inertia. Galileo ने एक word use किया है, inertia. So at Newton's first law is also known as Newton's law of inertia. Galileo's first law of inertia or Newton's first law is also brings out this term called inertia. We need to understand this now. What is inertia? If you think of a human being, then every human being is born with a little bit of something called stubbornness in him. And that applies to everyone. Me, Nidhi, Kirtan, Ashmita, सबके अंदर stubbornness है. Nidhi, go and get the remote. No, I'll not go. जाओ ना रत्नदीप से कुछ लेके आओ. Not now. Do you see? That habit is with everyone. Children, go to sleep now. No, एक थोड़ा और देख लेता हूँ movie. अगले दिन सुबह you want to be awake at night. Morning I go, सासरा उठ जा, थोड़ा और सो लेता हूँ. Whatever we ask you to do, you want to do ulta. So inertia is the inherent property of a body due to which it resists any change in its state. I explained it with stubbornness. So time now to remove stubbornness and understand inertia. So what is inertia? It is an inherent property. हर बॉडी में ये है. To resist a change in its state. बोले तो क्या? Change in its state means if you are in motion, you don't want to stop, and if you are at rest, you don't want to get into motion. बात समझ में आ रहा है? That is called inertia. अब inertia के कुछ examples देखते हैं. Let us see. Yeah. This is a metro cart. Okay, this is a metro cart, and people are all standing with one hand, as a one hand, and one hand out here. The metro is going this side, everyone is looking at this side. Okay? The metro is traveling with a constant speed. अचानक मेट्रो ब्रेक मार देता है, धाम से ब्रेक मार दिया. What do you expect? What happens to the people? They all move forward. ऐसा क्यों हुआ? इसमें इनर्शिया लगाओ. ये बॉडी बॉडी है, इसमें इनर्शिया है. ये बॉडी चलना पसंद कर रहे थे उस वक्त, आपने इनको अचानक रोक दिया. So what happens? The if you see the body before the cart has come to a stand stop, the cart is moving in motion and the people are also in motion. Means the whole body, everything of the body is in a translatory motion along with the cart. You suddenly stop the cart. Cart रुक गया, so your bottom portion of the body धड़म से रुक गया, but your body doesn't want to stop. सामने गिरते हो. Inertia. Newton's first law. A body in motion continues to be in motion unless and until it is acted upon by an external force, brake, to change its state of rest or of uniform motion. And what is the cause for it? Inertia. We are all standing like this. अरे यार पता नहीं मेरे क्या हुआ, अरे लाइन में कुछ सिग्नल नहीं है, अरे अभी भी ट्रेन नहीं जा रहा है, सिग्नल नहीं है. Then suddenly the train starts, all fall backward. Why? Everything of me was in rest. You pulled my leg this side, so the body balances by this side. Seat belts. Car. The seat belts. Why is the seat belt given to you? Because if suddenly a braking happens, your lower portion of the body till your hips will be on the seat, but your body will just bend forward and come, your nose will crash on that what? Dashboard. As a result, what we are giving? We are giving a seat belt. And the seat belt is also designed in a very nice way. The seat belt is designed in something called ELR seat belts. The seat belts that we wear in car are called ELR. Elastomeric locking retractor. Means if there is a slight pull, like you drop your mobile, you can wear the seat belt and you can come forward. Have you experienced that? If you wear a seat belt and you just want to say itch your leg or your knee, the seat belt allows you to come. But if you want to come suddenly forward, the seat belt doesn't allow you to come. Lock कर देता है आपको. That's why the accident पे आपको बचाएगा ना. And seat belts work miracles. Seat belts work miracles. किसी दिन दिखाऊंगा आपको तो आपको समझ में आएगा. ठीक है? So have you understood what is inertia? Now the question comes, sir, is the inertia of every body same? My inertia, Asmita's inertia? No. No. So how will we get to know who has more inertia? Mass. Mass is a measure of the inertia of the body. I have a pet mouse at home. क्या है? Hamster. Hamster को बुलाने से hamster आ जाएगा ना. I have one elephant also. ए बाबा उठना, उठना, चलना. उसका मास ज्यादा है ना, उसको inertia ज्यादा है. Suppose I have engaged Dhruv to move a big washing machine on Pebble corridor, and he is moving the washing machine, and right now washing machine is moving, so he is also moving. Imagine the washing machine is heavy and 4 kids come in front of him and do then what will he do? Because to stop suddenly is also difficult for him. Inertia. मोशन में है तो हम मोशन में ही रहना चाहते हैं. किसी भी भारी चीज का इनर्शिया ज्यादा है. That's why we say, why are you sitting on the sofa like a couch potato? बैठे हो. All you have developed in your body is inertia. You don't want to get up. So I have seen Nidhi Kirtan. In our class, we will say Kirtan has the least inertia. Should have. Morphologically, we say between Sahasra and inertia, inertia and Sahasra and Kirtan also we should say Kirtan should have least inertia. Physics. उसका मास सबसे कम होगा, हल्का पुल्का है ना. मैक्सिमम इनर्शिया इज विथ मी. अगर मैं सो गया एंड यू से उठो ना, उठो ना. कुंभकर्ण, हैव यू सीन इन रामायण? कुंभकर्ण हैज लॉट ऑफ इनर्शिया. हाथी को बहुत बड़ा इनर्शिया है ना. हाथी इज नॉट द किंग ऑफ द जंगल, and God has again blessed it with very big ears. So elephant is ignorant how big it is. That's why they say that don't run your business like an elephant. Means today I run business of girls cosmetics, and the fashion today is everyone wants hairband, but I would not buy. I'm still into bangle investing only. I'm like an elephant. I'm not going with the trade or the trend. Will customers come to my house shop? No. So an elephant when it goes and you tell the elephant turn left, elephant साथ साथ लेफ्ट नहीं टर्न करता है, ऐसे टर्न करेगा, ऐसे टर्न करेगा. बहुत इनर्शिया है इसको. वहीं अगर आप हैमस्टर को ले आओ, एक स्नेक को ले आओ, देखो तो स्नेक इमीडिएटली इधर इधर, उसका इनर्शिया कम है. So in management we say the least amount of inertia that you possess, the more you will be business wise viable. Children, you also study business studies, so don't give me that face as if you're not understanding. So if the business has got tailwinds and there is a change in business right now, नहीं मैं सबको ही बोल रहा हूँ, तो बिजनेस में हमें एजाइल होना है. इनर्शिया पालोगे तो कुछ नहीं होगा. प्लीज अंडरस्टैंड, याहू डिड नॉट वांट टू बाय गूगल. दैट इज ऑल इनर्शिया. नहीं चाहिए हमें वो सब. कोडैक डिड नॉट वांट टू, नोकिया rejected Android. Kodak rejected. Kodak was the camera when we were in kids. Kodak rolls, Kodak, 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 Kodak. Everything is Kodak. Kodak said no to digital cameras. Maybe your generation you have not yet heard about Kodak also. Kodak के cameras ही नहीं है. कैमरा बोलते ही आपको क्या आता है? Canon, Sony. But अगर आप देखो ना उस जमाने में the biggest company was Eastman Kodak. Everything used to be Kodak. Elephant था, inertia था. बिजनेस में इनर्शिया को जगह नहीं है. इफ यू शो टू मच ऑफ इनर्शिया देन you have to go by. And specifically where you are dealing with FMCG, I think you know what is FMCG. How many of you know what is the word FMCG stand for? Don't you give me that face. Business studies पढ़ते हो, FMCG, fast moving consumer goods. CS है तो फिर भी जानो. Fast moving, you write it down. Fast moving consumer goods is called FMCG sector. All these things. Phone is also nowadays an FMCG. Wristwatch, white goods like all these, refrigerator. People consider car also as FMCG now because Nidhi will say, oh look at them, Mr. Singhania bought a new car, we should also have a new car in our parking. FMCG. रत्नदीप में जाके जो भी आपको रैक में सामने दिखता है नियर द बिलिंग काउंटर, सब FMCG है. That's why they keep it there, and they will delay the billing till the child says, fuse. Some sales happen there. Do you know the product pays the maximum price to get stacked there in Walmart and all? Walmart and all, people go on Saturdays. So on Saturdays there will be huge queues in billing. Saturday, to get your product on that particular area of checkout, you have to pay the most premium price because you are getting the maximum viewership out there. An ad on an India-Pakistan day is the most chargeable ad. Because no matter what nonsense ad it is, we will see the ad. क्योंकि वो आएगा ही आएगा. आपका सबसे ज्यादा पैसा देना पड़ता है. एंड इफ केनिया इज प्लेइंग से पापा न्यू गिनी, उस एड का कोई दाम है? नहीं है, कोई नहीं देगा आपको. बिजनेस इज वेरी इंटरेस्टिंग. देन ऑल्सो have you seen stacks in Ratnadeep and other store? Four hands, Colgate, Pepsodent पीछे है. साहब हमारा Pepsodent सामने क्यों नहीं लगाते हैं? सामने का रेट दीजिए, सामने लगाएंगे. How do we buy soaps? On reachability. सामने लक्स है ना, उठा लिया. मैसूर सैंडल सोप थोड़ा और पीछे है. अम्मा एक मैसूर सैंडल सोप का कावाली, शी विल ब्रिंग लैडर. तब तक आप बोलेगा लेट हो गया, वो छोड़ो, नखले महीने लेंगे, लॉस. ब्रिटानिया लस्सी इधर है, विल्किन लस्सी वहां पे है. ये बदमाशी करते हैं. टेलीविजन में भी कर सकते हैं. नीचे एक लगाओ, एक ऊपर. रीच नहीं है. कंज्यूमर्स वांट्स टू फील, टच एंड देन बाय. मिनिसो देखिए आप कैसे रखा रहता है सामान. मिनिसो शॉप्स एंड ऑल, they are all by placements, they get their pricing. This is applied in all Costco, Carrefour, then your Target, Walmart and all. Yeah, anyways, we are studying physics, not business studies. Have you understood Newton's first law? And have you understood inertia? So Newton's first law, we say, defines force. We'll take 5 more minutes and then we'll release you. Kirtan, you have to go or you keep an eye. Newton's first law defines force. Now there are some more examples of Newton's first law. Take a take a cup full of water or a glass full of water like this. Take a glass and fill it with water and place a postcard on it. Place a postcard and put a coin out here. Put a coin out here. Who is heavy, postcard or coin? Coin. So who should have more inertia? Coin should have more inertia. So we will bring a change to the system. Take your finger and you hit this card. We brought a change. Who will resist the change more? The coin, because it has more inertia. ये कार्ड इधर उड़ जाएगा, कॉइन टपक करके नीचे गिर जाएगा. न्यूटन का पहला लॉ. समझ में आया? आर यू एबल टू मैरी इट और नॉट? बुक में इसका एग्जाम्पल है, लेकिन वो ऐसे आपको बताएगा नहीं. आप प्लेजर लो इस एग्जाम्पल का. कॉइन एंड कार्ड, हु इज मोर मास? हु हैज मोर मास? कॉइन. किसके पास इनर्शिया ज्यादा होना चाहिए? कॉइन. हु शुड बी मोर स्टबर्न हियर? कॉइन. Who should resist any change? Coin. Let us do the change. They are at rest and we just flick it like this. Who will fly away? Card. Coin will tuck करके नीचे गिर जाएगा. In fact, will end with this one more nice example. इतना सब पढ़ लिया. One day somebody gave me one SMS forward. Yeah, please. I got a WhatsApp forward, and in that WhatsApp forward, a story is like this. Have you seen truck drivers who bring logs and other delivery with them? So the truck driver pattern is like this. There will be a truck driver and there will always be a loader guy. In Hindi, we call the loader guy as khalasi. He is to help. Don't go by khalasi real. So he's supposed to help you, and the driver goes by his dignity. Driver's job, he will go and park in front of Pebble City, even if you see these Agarwal Packard cars that come, and then the driver will sit like a Lat Sahab. Rest the job is all the khalasi. He will unload and he will do. Again, driver's job is limited to only steering and to see loaded or not, right? So the message forward is like this. A driver one day drives a wagon full of log, and he is without his helper, loading guy. But however, his manager has told, जाके ये delivery करके आओ. But driver है, his ego works. मैं क्यों माल खाली करूँगा? Every log has to be taken and emptied. Nah, he will not do that. He says, I am a driver. ड्राइवर क्या किया? ड्राइवर took the truck. This is the truck, right? This is the truck, and all the logs are stacked like this. So he took the truck, went to the destination. रस्सी पहले से खोल के रख दिया है. Went to the destination, and right in front of the unloading area, took a steep right turn and immediately braked the car. All the logs fell. Then the message on Instagram reads, what was so funny about it? Scroll down. Newton's first law of motion exhibited by the car. A body in motion continues to be in motion. All the logs were in motion. Unless and until it is acted upon by an external force. The sudden jamming, dhram se brake maar diya na, to change the state of uniform motion. And net force acted on them. Khali. We all learned that driver was illiterate. He also did not understand. But what was applied was Newton's first law of motion. मजा आया? उसमें भी वैसे ही है. And I read that in my job life after so many years of studies के बाद भी मैं भी नीचे scroll करके गया. अबे what was so funny about it? The funny part is that you are so funny that you read everything you did not understand. This is Newton's first law of motion. Obviously they didn't write the topic as physics, otherwise we would have been thinking in that angle. But this is how it happens. Any system, if its state has suddenly changed, it means that a net force has acted on it. My achar bottle was right on the edge and I was watching television and I suddenly woke up due to the achar bottle falling down. Yes, rats are there in your kitchen. The rat, while moving, pushed your achar bottle. A body at rest was at rest unless and until acted upon by an external force to change its rest to uniform motion. And that time, you do not get up because now oil has spilled up. You are a fat couch potato. You have inertia. So whenever we want you to get up, the force acting on you should be enough to overcome your inertia. What is the enough force? If you don't get up, the oil is going to spread and more mess will happen. So the emotional pull that you are getting is overpassing your inertia. Tomorrow morning, our Ashmita doesn't want to get up. I will tell Ashmita, get up, तुम्हारे घर से बिल्कुल 100 meters दूर डायमंड के 4 बैंगल रहेंगे. अस्मिता आज रात से ही नहीं सोएगी पूरा, बिकॉज द फोर्स ऑफ पुल इज मच मोर देन द इनर्शिया ऑफ योर बॉडी. समझ में आया? एंड दैट इज व्हाट अगेन वी गो टू बिजनेस स्टडीज. We have to give you an offer such that you are already having Airtel fiber at your home. Why will you switch to Jio? ऐसा कुछ दो कि उसका inertia defeat हो. Sir, we'll give you the modem free, 1 month free, and we will give you 100 Mbps against it. Something great is there in this offer. You overcome. नहीं तो आप लोग बोलेगा है ना, चल रहा है ना, चलने दो ना. So Newton's first law defines force. Newton's second law, which we'll see in our next class, gives you a mathematical expression for force, that F equal to ma wala. And Newton's third law is very stylish. Till these law we always say force acting on a body, force acting on a body. Body को तुमने गुलाम बना दिया है. You are only acting force on the body. Body is your slave or what? Third law will first empower the body to also exert force. ऐसे फिजिक्स पढ़ो. थर्ड लॉ में बॉडी को हम एम्पावर करेंगे कि बॉडी विल नाउ गिव अप. मेरे को क्यों फोर्स दे रहा है, मैं भी फोर्स दूंगा. ये थर्ड लॉ में आएगा. हमारे साथ फिजिक्स पढ़ने से वी विल फिनिश कोर्स, बट नॉट दिस वे. ये हाफ पेज में न्यूटन्स फर्स्ट लॉ नहीं होता है, वो बेकार फिजिक्स है अकॉर्डिंग टू मी. इफ यू वांट आई कैन कंप्लीट इन दैट मैनर, बट